This is Team Alpha, and our project is a microcontroller enabled starter topology for the modern car. The teammates are Vasant, Chandana, Jerubal, Sriram, and Balkrishna. First, we'll go through the objectives, then we'll give a brief introduction and explain our proposed system in depth, the tools used, the methodology followed, the difficulties encountered, and the benefits gained out of our project. Here are our objectives. The first objective is to design a starter topology that ensures only authorized people are behind the wheels. Our second objective is to diagnose the starter faults based on the engine's internal sounds. So ours is a unique system that allows the driver to crank the car with his license. And another unique feature will be the starter fault detection based on the sounds, which we have done using Python script.
This is the proposed system. So for a starter motor to start, it usually needs a very large amount of current from the battery. So this is possible by using a solenoid. So when the driver inserts the key and turns it, the solenoid will be energized. Because the solenoid is energized, an iron rod will move and it will complete the contact between the battery and the starter motor. Hence, the starter motor will draw a large amount of current from the battery and it will start rotating. And hence, this starter motor in turn will start the engine. After the engine has started, the starter motor should stop rotating, or else it will draw a large amount of current from the battery and the battery will get depleted. Or if the starter motor is still engaged, the engine will rotate the starter motor at a very high speed and there's a chance of the starter motor becoming damaged. So then we'll be using here the neutral switch indicates that the starter motor cannot start when the car is in any other gear except the neutral gear. Here in our system, we'll be using a master microcontroller and a slave microcontroller. The master microcontroller will be interfaced to the RFID reader, the display unit, and the switch. And the slave microcontroller will be interfaced to the DC motor. So here, instead of a solenoid and the starter motor, we'll be using a DC motor. And instead of a key switch, we'll be using simple switch, and the RFID tag is used for extra security purpose so that only the authorized person and who has the license can start the car. So this is the design flow. Here the master microcontroller first will see if the switch is on. So when the switch is on, it will display in the display unit saying that ignition is on. Next, the microcontroller sees if there is a correct RFID tag match. So if there is no RFID tag match, it will keep reading until there is a correct RFID tag match. So when the microcontroller senses that this is the correct RFID, it will send a signal to the microcontroller, that is the slave microcontroller. So then when the slave microcontroller receives this data from the master microcontroller, it will display that power on and it will start rotating the starter motor. Here the starter motor will rotate for a few seconds and then it will stop, and then the process ends. Even though if you give the RFID input again, the starter motor doesn't start. So how this is beneficial is it can stop cranking, which can deplete the battery very fast.
I'm Sriram. I'm going to explain about the tools required for this project. First one is an RFID reader. Second is Atmega 2560, that is our master board. Second is Arduino Uno, that is a slave board. And for display we are using a 16x2 LCD display and a switch, relay, DC motor. The software is used Python and MATLAB. The RFID used is EM18. The pin configuration of the RFID reader, that is EM18, is the first pin is for VCC, power supply. The second pin is for ground. The third pin is used for a LED or a buzzer indication whenever we swipe the RFID tag. Sixth pin is used for selection pin, that is always set to high. And seventh pin is used for digital connection with the master board, that is 2560.
Hello guys, this is Balkrishna Range. I'm going to deal with the sound detection part of this project. There are many modules interfaced in this project. Each and every one will be going to deal according to their interest. So in this module, in this project, I'm working on RFID and even as a sound detection module. So I will be dealing with sound detection module. In this is the code. We can see that this is the Python code what I have typed, and this code works for sound detecting thing. As you can have a look on this thing. Now, whenever I used to run this program, whenever I click this, a certain module interface will come, PIO server and a scope, signal scope. This will show the frequency of the sound what we are going to speak, and this thing PIO server is used to record the sound. So whenever I will start this thing, whenever I will push this start button, it will start detecting the sound. And speaking, you can see that there are some deviation in the waveforms. Whenever I will click for the click sound, you can see these things, deviation. So we can easily detect the sound. So for this thing is used in the starter portion of the engine of the vehicle. So whenever the plunger will be engaged with that flywheel, no sound will be there. But if it is not engaged properly, so winning sound will come or clicking sound will come. If the winning sound will come, it will detect that thing and it will be displayed on the base panel of the driver. Knowing that the plunger has not been engaged with the flywheel properly, so no need of cranking it regularly. This will save your battery to get drained. This is the main aim of our sound detection part. But the thing is that you must be having some questions like it will detect each and every sound. So for that thing, we will use some glass sound proof module, in which this our project module will be there, which will be nearer to the starter module and solenoid module of the engine. So whenever there will be the sound, it will be detected by this device only, and no interference of sound will be there. So you can see this thing. This is the main part of our project. Okay, thank you. Cut that thing down. Hello friends, this is Balkrishna Nange. As one of my teammates Chandana has already explained the proposed system design, now let's see how it works. Initially, the ignition is off. It means that whenever we will put key to the vehicle, the first turn is to just power on the vehicle, so that it will be shown. We can see that it is still ignition is off. Now here, instead of key, we are using some switch. Whenever the switch is pressed, so ignition is on. Now you can see that to turn on the starter motor or cranking, and license is needed. So authorized person can only be able to start the vehicle. So this can be demonstrated as, so whenever the license is detected, that LED glows which indicate license is detected, and which will in turn lead to turn on the starter motor. A message license detected can be seen on the screen. Here we can see that this is the slave board and this is the master board. We can see this is the master board. Now key is turned off. You can see that ignition is off. So this is the prototype of our proposed system. Thank you.
Hello guys, my name is Jerubal and I will be mentioning the list of merits that can be provided by our proposed system. The first one is that it avoids inadvertent cranking. There can be many instances for a driver while driving when he might be prone to crank his car engine a second or a third time. Instances like when he's waiting at a traffic junction or during a traffic jam. So in such kind of cases, our proposed system of using an RFID tag reader prevents this because it allows the user to crank the engine once and once only. The second merit is that it prevents the starter motor damage. So there may be cases when the pinion may not get engaged onto the flywheel properly. In such kind of cases, it lets out a faulty sound. So such kind of sounds can be detected as mentioned earlier using sound detection mechanism using a Python code. And the next advantage is that our proposed system is highly secure and authentic because only the driver with his unique driver's license can be used to start the engine. So I'm going to mention some of the key benefits that we gained as a team ever since we started this project. We had a complete understanding of the starter operation and the different components used, and we also encountered the problem of overloading. So in order because we used a display, an LCD display, a relay and an RFID. So in order to fit all these peripheral devices, we went for the option of going with two boards. So the next task we had in mind was to perform a serial communication between these two boards, the master and the slave board. And to the master board we interfaced the LCD display and the switch. To the slave board we left it to do the operation of starting the DC motor on receiving message from the master board. And finally, the impact of grounding also hurt us while implementing the project because when using two different boards, it comes with two different potentials. So the impact of common grounding also played a major part. This project was actually done as a part of our project-based learning under the coursework of Automotive Electrical Systems as part of our MTech Embedded System and Technologies curriculum here at VIT Chennai campus. Thank you for watching the video. I hope you guys enjoyed it.